So welcome to Sotantra education. In this lecture we are going to discuss about the concept of polymorphism and abstract classes. So consider we have a class and name of the class is vehicle. So now assume in the vehicle class we have one method and the method is run, and in the run method we are writing one simple statement, that is system.out.println vehicle is running. Okay. Now consider another class, that is car, and the car class is derived from the vehicle class. So we can write class car extends vehicle, and assume in the car class we are overriding the run method. That means we are writing the run method in a different way. So different way means we are just printing car is running, instead vehicle is running. So if we redefine the method in a subclass, that is called as method overriding. So we have already discussed about method overriding in the previous lecture. You can refer to that one. So here we can write car is running. Similarly, we can write another subclass of the vehicle class and assume the name of the class is bus. So here we can write class bus, and in the run method we can write bus is running. Okay. So now let us define the driver class and assume the class name is test, and here we simply write the main method like this: public static void main, then string args, then here we can write vehicle, suppose v. That means v is a reference variable of type vehicle. In the previous class, while we are discussing the concept of inheritance, we have discussed that a superclass reference variable can refer to the objects of the subclasses. So following that, we can write vehicle v equal to new car. That means v, that is a reference variable of type vehicle, can refer to the objects of vehicle class or to the objects of the subclasses of the vehicle class. So here car is a subclass of vehicle class, so the reference variable of type vehicle can refer to the objects of car class. So here v is referring to the objects of the car class. That's why we are writing vehicle v equal to new car. Okay. Now we can write v dot run. So if we call the run method on v, then which method is going to execute? This run method is going to execute, that is defined in the car class. So let us check whether it is actually executed or not. So write java c, then test dot java. Okay, no error. Then java test. So it is showing car is running. That means this method gets invoked, and that is inside the car class. Now we can write v equal to new boss. So v can also refer to the objects of boss, and here we can write v dot run. Now let us execute this one. Okay, successfully compiled, no error. Then it is displaying car is running and boss is running. So this v dot run prints car is running, and this v dot run prints boss is running. So it is capital B. Here you can write, because we have written capital C for car and capital B for boss. Here car is running capital C and boss is running. Here you can observe capital B. Okay, anyway, so this v dot run prints car is running, and this v dot run prints boss is running. That means which run method gets invoked, that depends on the object v. So if v is an object of type car, then we can say this method gets executed. That means the method defined inside the car class. Now if v is an object of type boss, then this method gets executed. That means the method that is defined inside the boss class. And from here we can conclude that which method gets executed, or in particular in this example which run method gets executed, that depends on the object type of v. Now here you can observe, we know that the objects are created during the run time. So whether this method gets executed or this run method gets executed, that is decided at the run time. So we can say call to an overridden method is resolved at run time, because at run time the objects are created, and this mechanism is called as dynamic method dispatch. So what is dynamic method dispatch? So dynamic method dispatch is the mechanism that is called to an overridden method is resolved at run time, and this mechanism is called as dynamic method dispatch. So you can write dynamic method dispatch. So I hope this one is clear to everyone. Now we are going to highlight another concept that is based on the same scenario. So here you can observe this run method. So this run method, when the object is of type boss, this run method gets executed. When this object is of type car, this run method gets executed. So the run method is polymorphic, we can say, or this run method has different behavior. That means the behavior of the run method depends on the object on which it is called. That's why the run method acts differently on different objects. So we can say run method is polymorphic in this example. So here you can observe this run method is polymorphic. That means when the object is of type car, it acts differently, and when the object is of type bus, it acts differently. So we can say the run method is polymorphic. Polymorphic means multiple behavior. So the run method behaves differently in different situations. So we can say the run method here is polymorphic. And another thing you can observe here in this program, different objects refer to same message in different way. Suppose this run method is same, and so when the object is bus, this one gets executed. When the object is car, this one gets executed. So different objects refer to the same message in different ways, and this concept is called as polymorphism. So here you can observe, so this single program, in a single program we want to explain two concepts. One is dynamic method dispatch and another one is polymorphism. So polymorphism means different behavior. So here you can observe this run method behaves differently in different situations, and this concept is called as polymorphism, or this mechanism is called as polymorphism because the run method is polymorphic here, because run method behaves differently in different situations and different objects refer to the same message in different ways. So we can say this mechanism is polymorphism. So we can take another example. Suppose let's delete this one. Suppose class shape, we are taking another class, and here you can consider one method void area. Now here we can write system dot out dot println suppose area cannot be computed or calculated, so computed without a specific structure. So let's this one. Now consider class circle. So assume this class circle is a subclass of this shape class. So we can write and let us override the same method area. So void area. So here we can write this one. So we can write the formula area equal to suppose pi into radius into radius. Suppose just we are writing the formula. Now consider another class that is a subclass of the shape class, and assume this class is rectangle. So void area, so here you can write the formula, that is length into breadth. So here we are simply writing only one statement. You can take the values length and breadth as instance variables, and you can use constructor to initialize this, and then calculate the area, then write the area method. But for simplicity we are writing only the formula of the area. Now here you can observe, we can write shape, assume the object name is obj equal to new rectangle. So we can write in this way because the reference type of shape can refer to the rectangle objects. We have already discussed this one. Now here we can write obj dot area. Similarly here we can write obj equal to new circle, and here we can write obj dot area. So here you can observe the behavior of the area method is polymorphic. So area is polymorphic in this program, and this concept like which area method gets invoked depends on the object here. So when the object is of type rectangle, then this area method gets executed. When the object is circle, then this area method gets executed. So different objects refer to the same message in different ways, and this concept is polymorphism, or we can say the different methods behave differently according to the objects, and this concept is called as polymorphism. Okay, and here also during the execution time only the JVM can identify which method gets invoked, because the objects are created at run time only or execution time. So let us compile this program and check. Java C test.java successfully compiled, no error. So area equal to length into breadth, area equal to pi into radius into radius. So this one obj dot area, this prints area equal to length into breadth. So this statement it prints, and this one it prints area equal to pi into radius. This one it prints. So I hope this concept is clear to everyone about polymorphism. Okay, so before moving further, let us concentrate here. Here you can observe this area method gets never executed. In this situation or in this program, this area method never gets executed. And also here in the shape class we cannot find the area of a shape unless we say that the shape is a circle, or the shape is rectangle, or the shape is square, like that. So we cannot find or we cannot compute the area of a circle, sorry, we cannot compute the area of a shape. Now this method is never executed in this situation. So instead of defining the body of the method here, we can just omit the body of the method and just write this one, just give a semicolon. So as this method is incomplete, or we can say as this method is an abstract method, so just write this one abstract before the method name. So abstract void area. Now here you can observe the class shape contains one abstract method. So when a class contains one method that is abstract, the class name also should be abstract. So here we need to write abstract class shape. So similar to this, in this situation, many other situations are there where in the super class we just want to provide a structure of the method, and in the subclass we are defining the method completely, or we are defining the complete method in the subclasses, and in the superclass we are just writing the structure of the method. So in that situation we can go for the abstract method and abstract class. So now let us check this program whether it is working properly or not. So successfully compiled, no issues. So it is showing the same output, area length into breadth, area pi into radius into radius. Now here you can observe, as this class shape is an abstract class, you cannot create objects of this class shape. That means we cannot write shape obj equal to new shape. I cannot write like this. That means we cannot instantiate the abstract class. So if I write shape obj equal to new shape, then it is going to throw an error. Let us check. So it is showing one error, and the error is like this: shape is abstract, cannot be instantiated. Now here you can observe, we can write shape obj equal to new circle or new rectangle. We can write. Why? Because the class reference can be used to refer the objects of the objects of the subclass. So that's why we can write shape obj equal to new rectangle, and it works properly. This one. So I hope this concept is clear to everyone. The abstract class, the abstract method, and another thing is that in the subclass of an abstract class, we need to define the abstract method. And here, if you are not writing the body, suppose we have another method here, void display, suppose. So void display, and here just print system.out.println, suppose display shape, we can write this one, display shape. Okay. So here you can observe this abstract class has one abstract method and one concrete method. So let us check whether it is working or not. Okay, so it is showing the output. That means in an abstract class you can write the abstract method and also the concrete method. Now assume we have the circle class, that is a subclass of the shape class, and here we are overriding the display method, and here we are writing area equal to pi into radius into radius. In the display method we are writing that, but we are not defining the area method here. Here you can, in the class circle we are not defining the area method. Then what is going to happen? Let us check. So it is showing error. Circle is not abstract and does not override abstract method area in shape class circle extend shape. So here you can observe circle class is a subclass of the shape class, and in the shape class we have one abstract method area, and here we are not writing the body of the area method, or here we are not defining the area method. That's why you can write here abstract. The first thing is, in the subclass you need to write the definition of the abstract class, abstract method, or if you are not interested to write the definition of the abstract method, just write abstract here before the class name. Now you can see here it is not going to display circle is abstract, cannot be instantiated. Okay, so as circle is a abstract method, you cannot write obj equal to new circle, because we cannot create the objects of the abstract classes. So now I think it will display area equal to length into breadth. That means if you are deriving a class from the abstract class, you need to define the body of the abstract method, and if you are not interested to define the body of the abstract method, then just write abstract before the subclass. And like we have discussed, we cannot create the objects of the abstract classes.